Hey boys and girls, Mr. D here. In this video we're going to continue to work on becoming experts of exponents. Okay, so we're going to be looking at situations where we have the same bases and how to work with the same bases when they're being multiplied and those bases are raised to exponents, what we do there. So essentially we're going to be able to multiply exponential expressions with the same bases. An exponential expression is just any kind of expression with exponents in it. Okay, so let's take a look here. We'll jump right in with the first example, and it'll start to make a little more sense to you. All right, again, here's our rule, our steadfast rule. When in doubt, expand it out, and you'll see a lot of that in action today as we walk through some of this here. So here's example 1. Okay, 3 squared times 3 cubed. Notice we've got the same bases here. Okay, we're multiplying numbers with the same bases. So when we have that, we have a simple rule. Okay, that is, if you're multiplying the same bases, just add the exponents. So that's going to make sense here. We can go right in and we can answer that. I mean, we should all know what 2 plus 3 is. It's going to be 5. So our final answer would be 3 to the 5th. I know a lot of you guys have been really curious as to how and why those things happen. So let's take a look at the logic of it. If we expand it out, right? 3 squared is 3 times 3. 3 cubed is 3 times 3 times 3. So all these are being multiplied, right? It's 3 times 3 times 3 times 3 times 3. So here's what we have. Well, here's what we have, which if you count these 3's here, we got 1, 2, 3, 4, and 5. 3 to the 5th. Okay, so we really have 3 to the 5th, okay, which is 243. Okay, so 3 to the 5th should be 243. Okay, 3 times 3 is 9. Times 3 is 27. 27 times 3 gives 81. 81 times 3, 243. So when you become an old man like me, then you can do it all in your head. But for now, you could write that out in paper if you need to. Okay, so that'd be 9. Another way to think of it is that's 9. That's 9. Okay. 9 times 9 is 81. 81 times 3 is 24. Okay. So let's take a look at another example. Okay. Example 2. Now look at this. 5 to the 5th power times 5 to the negative 2nd power. Ooh, we're getting tricky here. Again, if you just follow your base rule, combine the exponents or add the exponents, right? 5 and a negative 2, well, that's going to give us positive 3. So we end up with 5 to the 3rd power. Take a look at how this works out the way it does. Okay? We know that we can rewrite this with positive exponents as 5 to the 5th over 5 to the 2nd power. Right? So if we expand it out, here's what we got. Now, if we think about canceling some things out, look, these 5's can cancel each other out. These 5's cancel each other out. What remains is 5 to the 3rd, or 125. Okay? Great, that's showing. That's as tricky as they get. We got a positive and a negative. So take a look at one more example here. X times x. Now again, if you think about it, what are really the exponents here? And there's no exponent. It's really a 1. So again, if you follow your rule, same bases being multiplied, you add the exponents. Well, we all know x times x is x squared. All right? It's the same thing. 1 plus 1 is obviously 2. Okay, so hopefully that helps clarify some things there. And again, you know, there's a lot of little exponential rules that we're going to cover here. This is the first of the few we'll talk about. You know, when you're dividing them, and when you're an exponent raised to another exponent, etc. When you have fractional exponents, we've already done some negative exponents. Again, you know, the real big key is this right here. You know, when in doubt, expand it out. It's especially very helpful with this rule here when you're multiplying the bases. A lot of times you get confused. Do I add the exponents? Do I multiply the exponents? When in doubt, expand it out. Okay? Hope this helps you guys. See you in class. Peace.